All right, so in this problem, in this video, we are going to look at finding the limit, and then we're going to use the epsilon delta definition to prove the limit actually is L. So here we have a limit as x approaches 1 of 5x plus 3. If we were to plug 1 in for x, we'll get an output of 8. I'm going to claim that is the limit. We're going to go through and we're going to see if we can prove that that is actually the limit. So some scratch work. We will have the absolute value of 5x plus 3 minus the limit of 8 is less than epsilon. We want to get that down to x minus 1 is less than delta. And so if we clean that up, we have 5x minus 5 is less than epsilon. We want to get to x minus 1 is less than delta. Again, that x minus 1 is coming from x minus c. The c is the value that we are heading towards, that our x value is heading towards, so that's why that's a 1 there. And we started off with f of x minus L is less than epsilon. So if you were to factor 5 out of this and then divide both sides by 5, we'd have 5x minus 1 is less than epsilon. So we're going to choose delta to be epsilon over 5. And so our actual prove it. Our proof is going to look like this. Given epsilon greater than 0, let delta be equal to epsilon over 5. Then 0 less than the absolute value of x minus 1 less than delta, which is epsilon over 5. So we would have x minus 1 is less than epsilon over 5, which implies really we're just taking the scratch work and we're going backwards with it. So it implies that 5x minus epsilon is 5x minus 5 is less than epsilon. This gives then the absolute value of 5x plus 3 minus 8 is less than epsilon, which is what we wanted to have. We wanted to be able to get back there. We just figured out what work was going to be necessary in that scratch work. Great. Let's do one other example, and we will be done with this section. So here we're looking at limit as x approaches 0 of the cube root of x. If you were to plug in 0 itself, you'll get 0. If you're to think about it, the cube root graph, that's what it's going to look like. Scratch work, we would have a cube root of x minus 0 is less than epsilon. We want to end up with x minus 0 is less than delta. So x minus 0, we could just call that the absolute value of x itself. So we have a cube root of x. It's less than epsilon. Cube both sides. So x, absolute value of x is less than epsilon cubed. And so our value of delta is going to be epsilon cubed. So again, that's our scratch work. It's not actually our proof. So now let's prove it. Given epsilon greater than 0, let delta be equal to epsilon cubed. Then 0 less than the absolute value of x minus 0 less than delta equals epsilon cubed. So the absolute value of x minus 0 is less than epsilon cubed, which implies the cube root of x minus 0 is less than epsilon. And that was our desired result. Great. So that is the proof. A lot of that proof happens in the work over here to the left, that scratch work. Right, so that scratch work doesn't show up in your formal proof explicitly. It's really showing up right there with those choices. All right. Next time we will look at some more definitions for limits. We will see you then.